All right, welcome back. So in the previous videos we had inscribed angles in circles, and now we've got polygons inscribed inside circles, right? So here we have a triangle whose endpoints are all on the circumference of the circle, and then we have a quadrilateral whose all four endpoints are also on the edge of the circle. Okay. All right. So we can solve question A just using the same kind of logic from the previous videos. So here we have angle X, whose measure is 5x degrees, and it produces an arc, which I'll color code in blue, okay, along the edge of the circle. Okay. Now, think for a moment, what do we know about this arc's measure, right? You know this arc's measure, right? Look at this circle. Let's rotate it this way. Let's cover up this half, right? WY is the diameter, right? It divides this circle into two semicircles, right? And so if a circle's full arc measure is 360, then half a circle would be 180, right? And so we can conclude that the measure of arc WY is 180 degrees. Okay, and remember that's going to be double of this inscribed angle. Okay, so that means that if we take half of this, half of 180 is 90, right? Then angle X would be 90 degrees, right? So this is a right angle. Okay, 90 times 2 is 180, right? So now let's go ahead and write an equation, right? 5x, which is the expression of this angle, equals 90 degrees, which is its actual measure. Okay, so divide by 5, and x equals, let's see, 90 divided by 5, 18. 18. All right. Now the second question, I don't know if we have the tools yet to solve this, so I'm going to do a very quick demonstration. Okay. So let's just start with a circle, okay, and then let's create an inscribed angle. Right. So I know that if this inscribed angle is x degrees, then the arc here, let's try to use these colors here. So the arc here would be 2x. Okay, and then if I were to make another inscribed angle, and I'm doing this so that the endpoints on the chords here match up with the endpoints of the blue chords, right? And I call that angle Y, right? Well, that inscribed angle produces that arc, which would be 2y. Okay, so if I look at my blue highlighted arc, which is 2x, and my green highlighted arc, which is 2y, those arcs combined form the whole circle, right? And the whole circle is 360 degrees, right? So now we can write this, right? 2x, which is the blue arc, plus 2y, which is the green arc, equals 360 degrees. But now check this out, right? Divide both sides of the equation by 2, and then you get x plus y equals 180 degrees. Okay? And so this is kind of the result that we need to use to solve part B, right? If you have some polygon here, and you have two inscribed angles that are, opposite each other, right, then their sum will be 180. Okay, so here, for instance, angle B is across from this angle here, 65 degrees, right? Those two angles need to add up to 180, right? 3A, that angle is across from 111 degrees, right? Those two angles have to add up to 180. Okay, all right, so let's go ahead and do that now. Okay, so I said angle B plus 65 has to equal 180. And then 3a and 111 also has to sum to 180. 3a plus 111 equals 180. Okay. So now we just have two algebraic equations which we're just going to solve. So subtract 65 from both sides. b is equal to 120, 115. Okay. Subtract 111 from both sides. All right. 3a is equal to, what's that going to be? 180 minus 111, 69. Okay, and then divide by 3. So a is equal to 23 degrees. Right? So that's a cool little result, right? If you have a quadrilateral, right, polygon, angles that are across from each other will add up to 180, and that's because their arcs, we know, would add up to 360.